So now this is my velocity function. When I take its derivative, what will I get? I don't mean derivative, sorry. When I take the integral of it, what do I get? The position, yeah. Okay, so let's see. We've got negative 9.8 t to the first power, so I add 1 and divide by the new exponent. V sub 0, is that a constant or is that a variable? Yeah, it's a constant, so I'll treat it like I would any other constant. Over here, I would have t to the 0 power, so I would add 1 and divide by the new exponent. Am I done? And the answer, no. I have to add that constant of integration. So I have now s of t is negative 9.8 divided by 2. Negative 4.9 t squared plus this term becomes v sub 0 t plus c. Okay, now let's do the same logic that we did up here on this one. What if now remember, s of t is position above the earth. What does s sub 0 stand for? The initial height above the earth. You know, if I'm going to stand 10 feet off the ground and throw something, it's going to have a different position against above the earth after 2 seconds than if I stand down here and do it. So we have then that, using the same logic as here, that if at time 0, another way that we express at time 0 where the object is to call it s sub 0. And if we have that at time 0, then we've got negative 4.9 0 squared plus v sub 0 times 0 plus c. So I'm just saying at time 0, this is where the object is. And what I can come up with is then that s sub 0 is the same thing as that constant. So what is s of t? Negative 4.9 t squared plus v sub 0 t plus, make a substitution, s sub 0. Is that the position function we were supposed to get to? Yeah. And so again, we're solving a differential equation. We're doing exactly the same thing. Okay. Okay, I think let's see, look at our time here. I think what we'll do is I'm going to leave this section as it is, and I want to get into section 5.5A, make sure that we have time to talk about that. Now,